All right, this week we are going to be talking about version control systems, and this is something that you've probably thought about. You've most of you have probably used some kind of version control system, even if you didn't realize that you were, even if you didn't have that term attached to it. And so version control is basically just a system for keeping track of the history of your files and the changes you've made to those files. And so usually we think about this in the context of particular projects. So it could be a chapter for your thesis or a manuscript or a class project, whatever. And there are a number of different reasons why version control is a good idea to use. Some are just practical, right? So it's always good to have a backup. You never know when something might happen to your computer. Version control is a way of doing that. Um, Things also get complicated as you move forward, as your projects grow in complexity, and as you kind of accumulate more and more projects on your computer. Um, and there's a joke that you from 6 months ago doesn't answer email. And so if you have a good version control system, then you'll actually be able to see what has changed throughout time relatively quickly and restore those changes if you need to. In a scientific context, it's also a great way to increase transparency and reproducibility in your work. And so this might be something that many of you have done before, like I said. So kind of the common systems that people fall into are to use something like Dropbox or Google Drive. So if you use those just to sync files and you just edit files on your own computer, then it's kind of the backup, and they actually do keep a version history. So you can go back and see how many times you've changed the document and restore those old versions if you like. If you're working on Google Docs, then it's a bit more nuanced too, actually, because they essentially do that for every time it auto saves, you have a version that's saved. Um, Another thing that people tend to do is to maybe periodically copy a folder to an external hard drive. If you're really good, you might kind of keep multiple copies of the same folder and rename the folder each time, like add on the date or something like that, so that you actually have a history of what the folder looked like through time. You might do something similar to that within a folder where you rename revisions as you go. So you have like, I don't know, chapter one, version two, version three, et cetera, et cetera. And each of these systems, they they work. They have some shortfalls. One, they're prone to error. They're prone to confusion because you don't necessarily know if you're looking at past versions or past dates. You don't necessarily know what is different about those versions. They also require you often to manually do things, so they only get updated as often as you remember to plug in your external hard drive and copy over the folder, or as often as you feel like doing that. Which maybe it's a lot at the beginning, but as time goes on, people have a tendency to kind of trail off on their frequency of things like that. And this is a well-known problem actually in the academic world, where a lot of times you're working with multiple collaborators, and so say you're writing a draft. This is a PhD comics making fun of this, where say you have this draft and you think you're done, you name it final doc, and then you send it to your advisor and you get comments back, and then you have to make revisions based on those comments, and you get more comments, and then more revisions on the comments, and then more comments on the revisions, and then you end up with this long string of files, and you have final underscore really seriously final, and it gets really confusing really quickly. Generally you want to keep copies of all of this rather than just overriding the file, so that if you do go to, like in the future, if you do realize like, oh, actually I had this paragraph that was really good, that I want to draw from, then you still have a copy of that somewhere. It's just a matter of finding it. And so this can happen not just with manuscripts, but say you're cleaning data sets or processing data sets for different reasons. It's very easy to have things get out of control very quickly. Right? And so all of these systems, like I said, they work, but they have some serious shortfalls. And so a version control system is basically a formalized way of dealing with this problem. It's a version control system is a piece of software that actually keeps track of changes to a file or to files within a directory or folder over time. And believe it or not, this actually has a long history of use with software developers and programmers. So when you're writing code, it's good to have a record of your code. Kind of like in academia, you might be collaborating with multiple people, and so you have a lot of the same issues. But programmers have the tools to build software, unlike, say, most biologists, to deal with this problem in a more effective way. And so there are three main kinds of version control systems. You might have a local version control system where here you're just working on your local computer, this grayish box, and you have a database on your local computer. And that database has copies of each version, right? So you have the project version 1, version 2, version 3, dot, dot, dot. And when you want to work on a particular file, you can check it out of the version database, work on the file, save it, and then send it back and essentially add a new version, version 4 in this case, right? So everything is just within your local computer. That of course still has a lot of downsides, right? So if you're unlucky enough to have your hard drive crash or files get corrupted or something like that, it might take out the entire version database and then you've just lost everything. It also isn't great for collaboration, but if you're just working on your own, it's an okay system. Centralized version control systems deal with the problem of having it just on your own personal computer, and it also makes it a little bit easier to collaborate. So here, that version database, rather than being just on your local laptop or desktop, is actually off on some central server. So this could be something that you set up through university, but this is actually how things like Google Drive work too. So Google actually keeps the original copies, keeps the version database on their servers, and then you, computer one, or your friend, or maybe on a lab computer versus your home computer, you can download and check out particular files and work on them. But when you do that, you just get the files, right? So if you have a Google Doc, you can download it as a .docx or whatever, and work on it and save it, and then re-upload it, right? Just like with a local version control system. But here you're uploading it to the central server. But when you do that, you only get that file. You don't have the full version history, and you don't have the full capabilities of what you could do if you had that full version history. So that brings us to the third type, distributed version control systems, where here you still have often some remote server, right? So that's this box in the middle that has the version database. But when you are working on your own local computer, you actually download the entire version database, right? So not just that one particular file, but that file and its full version history, and typically the entire project folder if there's more than one file associated with it. So then when you're working on your own computer, you make changes to the file, you save it, and you store those into your own local version, your own local copy of the version database. And so on your own local computer, you might have version 4 added. And then when you're ready, you can upload that to the central server. Right, so the central server would then have your updated version database that has v4 in addition to 1, 2, and 3. Right, and so this might seem a little bit confusing right now, and it is a little bit confusing, but hopefully things will become a bit more clear as we go. Right, and so version control systems, it's kind of a category of software. So it's like if you said word processor, that could mean Microsoft Word, it could mean OpenOffice, it could mean Apple Pages, Google Docs, whatever. There are all these different types of word processors, and each has their own strength, their own weakness. And so when we say version control system, that's the general term. And the type of version control system that we're going to be focusing on is called Git, G-I-T. And Git is a type of distributed version control software. So that's the kind when you're working on your computer, you actually download the full copy of the version database, and you upload that full copy of the version database to the remote server, and your collaborators can download the full version database. Right, so on every single computer that has worked on this project, you have a copy of this full version database. And so thinking about it like that, that's actually, it makes your project as close to indestructible as it gets. right? So it's not just on your computer, it's not just on your computer in Google Drive or Dropbox. It's on your computer, it's on this remote server, it's on your lab computer, it's on I don't know, your friend's computer, your collaborator's computer. You can download it in a bunch of different places. And so you have all of these backups in case anything happens to any one of them in particular, right? So it's really robust in terms of saving your work kind of in perpetuity until you decide actively to get rid of it. And the way that Git works is that it actually stores snapshots of all of the tracked files within your working directory. So the directory is kind of an interchangeable word with folder, and then we also have this term repository when we're talking about Git and version control, where repository is just the folder that is being tracked. Right, and so if you were thinking about ways that you could build a version control system, this is one of the ways you could do it, where each time you have a snapshot of the files, so you have the full files in every version within your version control database. You could also keep track of just what changed between version 1 and version 2, between version 2 and version 3. So then if you wanted to, you could go back in time and kind of patch together those changes. But the way that Git does it is sort of akin to if you copied a whole folder and uploaded that, but it does it in a more efficient way. So if we look along I guess the x-axis here, we have check-ins over time. So we have version 1 that has file A, B, and C. We have version 2. Version 2, we updated file A and we updated file C. So Git actually stores full copies of A1 and C1, but B didn't change. So instead of kind of wasting memory, wasting resources, and copying B again, it just puts a little pointer that points back to version 1 for file B. Right, so it's a bit more efficient. And if we look at version 3, here only file C changed. So we have C2, and that's uploaded as a whole, stored as a whole. File B hasn't changed, so that's still pointing back to version 1. File A hasn't changed, that's pointing back to version 2. And so on and so forth, right? And so this is kind of the like guts of how it's working. It doesn't necessarily affect how you actually interact with it. And so the general process here, if we think about our distributed version control system, is that when you're working on your own computer, you save your file, you store your changes locally, and then eventually, once you're ready to, you can push that. That's the verb we use, push, to a remote server. And there are a bunch of different websites that are happy to host your Git repositories, your repos, your directories. And one of the more common ones is GitHub, and that's what we're going to be using this week. So say you're using Git, which we'll get a chance to. What you would usually do is once you have your repository all set up and established, you have your files that are being tracked by Git, is that you open up whichever files you're working on, you type, write some lines of code, write a paragraph, whatever, and you save those changes just like you normally would. And so this is all happening within your working directory, where your working directory is kind of the location on your computer where this folder is, where your repository is. Next, say you hit a place where you've, I don't know, finished the code for processing a particular data set, or maybe you've written a paragraph of your discussion. You reach a place where you're kind of ready to store that as a new version. The first step is to stage your changes or stage your fixes. And that moves things, basically it tells Git, hey Git, check out these files, see what they look like now. That's what I'm going to want to upload in my version database. Right, so you've staged these files. It's kind of an intermediate staging area. So they're not in the version database yet. You can actually change your mind and unstage them. But staging basically tells Git, look at the files as they are at this point. That's what I want to put into the version database next. So after you've staged a file or files, if it makes sense, then you commit those changes. And when you commit, basically you're taking them from the staging area and putting them into your local copy of the version database. So here that would add a new version v4. So that would be the updated files in the Git repository in the version database. And you can go through that cycle from 1 through 3 as many times as you want on your local computer. So say you're, I don't know, on a bus or on a plane or something, you don't have access to the internet. That's not a problem. You can keep working, keep staging, keep committing changes into your local copy of the version database. And then when you do get access to the internet, you can push all of those commits at once to the remote repository. It's also perfectly fine to, if you do have access to the internet, to stage, commit, and push, stage, commit, and push, and always push right after you commit. There's kind of no reason not to if you do have access to the internet. Right, so that's kind of the basic way that you would use Git. Um, and in videos 2 and 3, we'll go through how to get your computer set up so that you can actually work on Git. And then in video 3, how to actually use Git and some of the cool features that come along with GitHub. Right, and so the benefits of using version control and kind of Git in particular, which is what I'm most familiar with, is you have this record of all of the changes that you thought were significant enough, at least to commit, for whichever project you're tracking. Right, so you have the full copies of the files, you have timestamps for when they were committed, and Git actually forces you to write short commit messages each time you commit. So at least in theory, you've written something out describing what's different about that file. So you could say, wrote or expanded the discussion, or revised the introduction, or added code to summarize this data set, or whatever. Right, but there's something there so that as you're scrolling back through time, you don't just have version 1, version 2, version 3, version 4. You have something a bit more informative about what's different about that version. Git also makes it very easy to collaborate with people on a project. Depending on where you are in your career, this might be something that you've kind of started to deal with, at least with your advisor maybe. And Git has a lot of tools for allowing you to say two people work on the same file simultaneously, and then you can basically merge those two files together, right? So in that way, it's sort of similar to if you're working on Google Docs and two people working simultaneously. It's a little bit different, but same general idea. Git also allows you to create parallel branches of projects. So you can you've been developing this project and you decide, well, actually I want to have it go this way first. Maybe you're, I don't know, designing something for a class, and so you have one branch that is made for kind of the introduction version, and then another branch that gets developed further for a more advanced class, like an upper division class or something like that. The other cool thing that Git has is that it shows you the user history. So you can look at a file line by line and see who changed what when, right? So along with the commit, you have the commit message, the timestamp, and who did that commit. So if you are working with a group of people, you can see exactly who wrote each and every line of code, or each line within the manuscript or whatever. It also integrates really easily with RStudio, so we'll go through how to do that. So you don't actually need to use the command line almost ever. You can just do everything by pointing and clicking in RStudio. And in terms of kind of the scientific benefit, you can hopefully see that this would make your work much more reproducible and much more transparent. If you have this full version history and you make that publicly available, first off, you're publishing your code for other people to look at. But you're not just publishing kind of the end result of the code, you have the full history there. So someone can look through, say you're building a model of some kind, they can look and see how that model developed over time, maybe what you tried out and didn't work, what you ended up with, and how and why you ended up there. And so that can be really valuable if you're using someone's model as a guideline, essentially as a jumping off point to start your own model. It can be really, really helpful to have all of this detailed information. And then lastly, as projects get more complicated, it's easy for your folder to get very disorganized very quickly. And Git helps with this in a few different ways. One is that you're tracking individual files through time. So you don't you're not shuffling files all over the place regularly, right? It helps to have a little bit of forethought about, all right, well, which folders do I want to have for this project? What makes sense? If I am writing code, how many different scripts am I going to have? What's going to be in each R script, etc. And you don't end up with, data cleaning underscore v1, data cleaning underscore v2, data cleaning underscore v3, right? You just have the same file that you can look at its history instead of storing each one as a separate file in your folder. So that's it for the introduction. Hopefully that was a little bit informative. And next we will move on to getting you set up in RStudio and with Git.